In this video here, we're going to take a look at the eccentricity. So we saw in the previous chapter how we could define a parabola in terms of its focus directrix properties, and we can also do the same here then with the ellipse and the hyperbola. So for all points P on a conic section, the ratio of the distance of P from a fixed point called the focus and a fixed straight line called the directrix is constant. And this ratio E is known as the eccentricity of the curve. So moving on then, what does the eccentricity tell us? Well, if E is strictly between 0 and 1, the point P describes an ellipse. If E is equal to 1, the point P describes a parabola. And then finally here, if E is strictly greater than 1, the point P describes a hyperbola. Now we do also have two special cases, so this is when E equals 0 and E equals infinity. So when E equals 0, this represents a circle, and when E equals infinity, this represents a straight line. Okay, but this is a little bit beyond what we need to know here for this video. So let's take a look now how we actually find the eccentricity for an ellipse. So for an ellipse here with this standard equation, so we have x squared over a squared plus y squared over b squared equals 1, and a is strictly greater than b, then the eccentricity will be between 0 and 1, and is given by the following result here. So we have b squared is equal to a squared times by 1 minus e squared. The foci are at plus or minus AE and 0. And then finally here, the directrices are x equals plus or minus A over E. Now we do have to be careful here if B is strictly greater than A. So if B is strictly greater than A, the eccentricity is again between 0 and 1, but is calculated slightly differently. So in this case then, the eccentricity is given by A squared is equal to B squared times by 1 minus E squared. The foci are at 0 and plus or minus BE. And then finally, the directrices are y equals plus or minus B over E. Okay, so that's everything here then for an ellipse. And finally, to finish with here then, for a hyperbola with our standard equation here of x squared over a squared minus y squared over b squared equals 1, the eccentricity, E, is strictly greater than 1, is given by b squared is equal to a squared times by e squared minus 1. So just notice here then, this is slightly different to the way that we find the eccentricity for an ellipse. The foci are at plus or minus AE and 0, so just the same here as an ellipse. And then finally, the directrices are x equals plus or minus A over E. So again, just the same here as an ellipse. So there we have it, right? That concludes everything that we need here for our introduction to the eccentricity for a hyperbola and an ellipse. So all we're going to do now is just put through a couple of practice questions here for the eccentricity. So let's get started with question 1 then. So for question 1 here, we have the ellipse E, which has the following equation. So just in case you can't read this, maybe if you're on a mobile, for example, the equation of the ellipse is given as follows. So we have x squared over 9 plus y squared over 4 is equal to 1. Now for the first part of this question here, part A asks us to find the eccentricity for the ellipse E. So starting off with part A then, where all we want to do is find the eccentricity. So for the eccentricity here for an ellipse, this is calculated as follows. So we have b squared is equal to a squared times 1 minus e squared. Okay, so b squared here is 4, a squared is 9. Okay, so we get 4 is equal to 9 times 1 minus e squared. Okay, expand the right-hand side out here, so we get 9 minus 9e squared. I'm going to add 9e squared to both sides. I'm also going to subtract 4 off both sides here. So if I do that, what I get then is 9e squared is equal to 9 minus 4, which gives us 5. Okay. Obviously, the next step here is to divide both sides by 9. So I get e squared is equal to 5 over 9. Now, if we just want e right, all I need to do here is take the square root off both sides. So e in this case here, don't forget we also need the negative solution. So we get plus or minus the square root of 5 over 9. Okay, But clearly we can simplify this here, right? Because the square root of 9 is 3. In that case, then the eccentricity here for the ellipse E is given as plus or minus the square root of 5 over 3. Okay, so there we have it. That gives us the solution to part A. Now for part B then, it says find the foci of the ellipse E here. So for the foci then, don't forget that this is given as follows. So it's coordinates, right, for the foci. We get plus or minus AE, my x coordinate, and then 0 for my y coordinate here. Okay, so in that case then, A here, that is square root of 9, so that would be 3. We then times that by E here, which is root 5 over 3. So 3 lots of root 5 over 3, the 3's would just cancel, right? And I get left with plus or minus root 5 here. Okay, so in that case then, the foci here, we get plus or minus root 5. And for my y coordinate, we simply get 0. Okay, so that gives us the solution to part B. And finally then for part C here, which wants us to find the directrices of the ellipse E here. So for part C then, just recall that the directrices of the ellipse E here would be given as follows. So let's just write this down here. The directrices are given as, so we get x equals, so x is equal to plus or minus, so plus or minus A over E. Okay, as we've already mentioned, A is the square root of 9, so A is 3. So what I'm going to get here then is x is equal to plus or minus A, which is 3, divided by E, which is root 5 over 3. I get 3 all over root 5 over 3. So if we simplify this here then, nice and straightforward, this is just the same as plus or minus 9 over root 5. Okay, and there we have it. So nice and easy. That gives us the solution to part C, and that gives us the solution there to question 1. So moving on to the very last question here, then question 2, where we now have the hyperbola h, which has this given equation here. Now for the first part of this question, then part A, all we want to do is find the eccentricity for the hyperbola h. So for part A then, for the eccentricity here, so that's E, the way that we find this is as follows. So it's b squared is equal to a squared times by e squared minus 1. Okay, and just notice here then the difference for finding the eccentricity for a hyperbola and an ellipse. Okay, so a squared is 25, b squared is 16. So putting that all together then, we have 16 is equal to 25 times by e squared minus 1. Okay, so it's up to you how you go about solving this here, whether you just divide through by 25 straight away, or you expand here, it's completely up to you. So if I was to expand, I get 25 e squared minus 25. So let's just add 25 to both sides here. So we get 25 e squared is equal to 16 plus 25, so that's 41. Then let's divide both sides by 25 here, so we get e squared is equal to 41 over 25. And then finally here, just take the square root of both sides here to get e then. So e is equal to, don't forget the negative solution as well, right? So plus or minus root 41. So we get root 41, well, the square root of 41 over 25, which we can then simplify to give us the following. So e is equal to plus or minus. So we get root 41 over the square root of 25. Well, the square root of 25 is just 5, right? So we get root 41. So root 41 over 5. Okay. And there we have it then. So that is the solution to part A. Now for part B then, we now want to find the foci of the hyperbola h. So for the foci here then, just recall that the foci is given as follows. So the foci here is coordinate. So it's plus or minus AE for the x coordinate. And for the y coordinate, then it is 0. Okay, so let's just write that down. So plus or minus AE here for the x coordinate. And then for the y coordinate, nice and straightforward, it's simply 0. Okay, So in that case then, what we get here is the following. So we get plus or minus, so plus or minus. So a then, that is the square root of 25, so that's 5. So I get 5 times by root 41 over 5. So in that case then, the 5s will just cancel, right? So all I actually get left with here then is plus or minus root 41. Okay, that's my x coordinate. And again, my y coordinate is always just 0. Okay. And there we have it. So nice and straightforward. That gives us the solution to part B. And then finally here for part C then, all we want to do now is find the directrices for the hyperbola H. So for part C then, for the directrices here, let's just write this down. So for the directrices here then, just recall these are given as follows. So it's x equals, so x is equal to plus or minus a over e. Okay. So in that case, then what we get here is x equals plus or minus. So a, again, as we've already mentioned, is just 5. It's the square root of 25. So I get 5 all over e, which is root 41 over 5. So root 41 over 5, which if we simplified this here, right, would just be plus or minus 25 over root 41. So 25 all over root 41 here. Okay. And there we have it then. So that gives the solution to part C and the solution to the very last question, question 2. And that actually brings us to the end then of this video here on the eccentricity.